Hello everyone, my name is Anaya Sharma and this is my presentation on the journal article Daily Marijuana Use is Not Associated with Brain Morphometric Measures in Adolescents or Adults. I chose the article Daily Marijuana Use is Not Associated with Brain Morphometric Measures in Adolescents or Adults. I chose this article because I wanted to know more about how marijuana affects adolescent brains. I have read the effects of marijuana on adults, but have not read enough on the effects of marijuana on children. Marijuana must affect adolescents differently than adults due to their malleable brains. This article is related to our studies in physiological psychology because in the Brain Facts book, in Chapter 13, Addiction, a whole section is dedicated to marijuana and the effects of it. The textbook describes positive and negative attributes of marijuana and what exactly marijuana is. The study's main research question is, does marijuana use affect volumetric and shape differences in the brain in adolescents and adults? After figuring out a research question, it can be rewritten into a hypothesis. The hypothesis for this study is marijuana use creates volumetric and shape differences in the brains of adolescents and adults. The researchers found that in other studies, marijuana use did create volumetric changes in brain structures. They sought to replicate this. The main objective of this article is to identify how the use of marijuana affects the brain and if there are structural changes due to its use. It will highlight the relationship between marijuana and the brain. Operational definitions are important in a study because they show how each term is going to be identified in the research. Marijuana in the study is studied as a cause of structural changes in the brain and volume changes in each structure. The effects of marijuana were studied as a cause of brain abnormality. Marijuana use was identified by an assessment taken by participants. The next operational definition, voxel-based morphology, is defined in the study by being the way that the researchers investigated gray matter differences in the control brains and the brains affected by marijuana. Lastly, the nucleus accumbens, amygdala, hippocampus, and cerebellum were defined by means of MRI scanning, checking to see any brain abnormalities or structural or volume changes due to marijuana. Some important concepts that will be talked about are confounding variables, subcortical structures, and brain morphology. A confounding variable is a factor that is different than the independent and dependent variables, which influences both these variables. This causes a spurious association. A spurious association is when factors appear to be causally related, but are not. Any observed dependency is just due to chance. Subcortical structures are a group of structures in the brain that include deep white and gray matter structures. They are deep within the brain and include limbic structures, the pituitary gland, the basal ganglia, and more. They are involved with memory, emotion, pleasure, and hormone production. Lastly, brain morphology is a study of structural measures of the brain, including the volume and shape. Brain morphology is super important in this study because it will help researchers identify the volume of subcortical structures because of marijuana. In total, there were 79 participants who used marijuana and 79 control participants. Out of the participants who used marijuana, there were 29 adults, 16 males and 13 females, and 50 adolescent participants, 41 males and 9 females. Out of the control group, there were 29 adults, 16 male and 13 females, and 50 adolescents, 36 males and 14 females. The participants of this study were selected from Albuquerque, New Mexico, or Boulder, Colorado, through an advertisement for studies on alcohol and substance abuse. The adolescent participants were recruited through Juvenile Justice Services in Albuquerque, New Mexico, as a part of a larger study on risk behavior of adolescents. There was exclusionary criteria that included the use of psychotropic medications or a diagnosis of a psychiatric disorder excluding ADHD. This is since these medications and disorders can have physical effects on the brain that could alter the results of the research. The participants who used marijuana were aged 19 to 53 in adults and 14 to 18 in adolescents. The control group was aged 18 to 53 in adults and 14 to 18 in adolescents. I believe this research could have had a more representative population of participants. There is a significantly greater amount of males compared to females. However, the age range of the participants is strong and covers a wide range. There is no information about if they factored in economic backgrounds, but they do have little information about the education of each group. Both adult users and non-users had an average education level of 13.5, meaning what grade they completed. The adolescent users and non-users had an average of 9.16 and 9.08 grade levels respectively completed. The design for this study focused on the effects of marijuana usage on the brain and looked at brain scans that depicted white and gray matter volumes and structural differences. To identify substance usage, participants had to complete an assessment called the Timeline Followback to identify quantity and frequency of substance use for the past 60 days. Participants also had to take a personality questionnaire and a depression and anxiety inventory test. The independent variable is marijuana usage, and the dependent variable is the abnormality in structure or volume of subcortical structures. There were two confounding variables, alcohol use and cigarette smoking. These two variables had to be accounted for so that they could be controlled. They also needed to be identified so that any structural changes wouldn't be because of these variables. The experiment started with the completion of assessments to identify the usage of marijuana and alcohol dependence in each participant. Cigarette smoking was also recorded as another confounding variable. There were exclusions applied to the participants. No psychotropic medications, or no diagnosis of any psychiatric disorder other than ADHD. After that, the anatomical scan imaging of the brain was acquired from a T1 scanner, and voxel-based morphometry volumetric density analysis were performed using the program FSL-VBM. Two separate analyses were performed to assess the amount of gray matter volume in the brain and to also check the volume of the nucleus accumbens, amygdala, hippocampus, and cerebellum. There were multiple comparison corrections to standardize the results. There was a threshold put on the scans to create an expected false discover rate of 5%. This helps control unexpected error rates due to the multiple shape analyses. To make sure the results were as accurate as possible, audit scores and ages were identical in the control groups and the marijuana users. There was also no significant difference between the measures of the confounding variables like alcohol and tobacco use. The results of the study were that there was no significant effect on the subcortical structures due to marijuana use. Even though in the adolescent group there was a difference in the right hippocampus, it didn't meet significance after multiple corrections to the research. To ensure the higher levels of alcohol were not masking the effects of marijuana use, the analysis was repeated using participants with low audit scores, which indicated less alcohol consumption. The graph on the left shows the study's findings while also showing the effect sizes for marijuana users and control groups in other studies. The major conclusions from this research were that structural abnormalities in subcortical structures are not connected to marijuana use. There was no significant evidence of differences in volumes of the accumbens, amygdala, hippocampus, or cerebellum due to marijuana use. Another conclusion is that alcohol needs to be carefully monitored in studies like this because it is known to cause volume loss in brain structures. This could cause inaccurate results. This is why researchers went back and retested people who had low alcohol audit scores to make sure their findings were correct. There was no significant conclusion that can be made of the results because the sample size was too small. There needs to be a study with a larger sample size to accurately portray the results. However, the lack of significance in this study is consistent with observations made in other studies published previously. The practical implications of this study are limited due to a small sample size and a lack of a longitudinal study. A longitudinal study could be very helpful because it would be able to show the effects of marijuana use over a long period of time. This could help show that marijuana may not have significant effects over a short period of time, but may have more significant effects if taken for an extended period of time. Longitudinal studies need to be done to determine the longevity of marijuana use compared with volume of subcortical structures. Further research needs to focus on how marijuana is consumed, whether it be smoking or edibles, so that it can determine how and which cannabis components impact the brain. Nevertheless, there are some practical implications of this study. This study was created to inform the public and policymakers about the risk and benefits of marijuana use and to correct the misinformation about the long-term effects of marijuana. It is important that the right information about marijuana is being spread so that objective policies can be made. Here is the complete APA citation of my article. Thank you so much for watching my presentation.